So today we're learning about compound inequalities. You'll notice that I do not have a chapter and section. Yesterday we learned 4.7, and if you were to look in your textbook, that is technically the last section of your chapter. However, in Algebra 1, early on in the year, it's like chapter 2 in the year, there's a really heavy focus on compound inequalities. So what I want to do is just introduce you to this topic. And even though it's not technically in your textbook, it's very important, and I think that you can do very well on this concept. So we're just going to lay the groundwork. We're going to lay the groundwork here. All right, so what is a compound inequality? It's formed by joining two inequalities together. Okay, and that's, how many of you have learned a compound sentence? You guys learned compound sentences in English, right? So a compound inequality kind of has that same concept, all right? The same idea that I'm joining two inequalities together by two words, and or. And those two words are very important. I need to be able to recognize whether it's an and statement or if it's an or statement. And I'll try to teach you some very key ways that we can tell the difference between the two of them. All right, so we have that? All that filled in? So in example 1, okay, this should say number x is greater. Okay, so it should say greater. You can put in the ER. Okay, a number x is greater than -8 and less than or equal to 4. What you must understand is that both of these values, -8 and 4, are both being compared to x. And what does x stand for? X stands for the solutions. Okay? It stands for the solutions that would make it true. We've been kind of practicing that dialogue, haven't we? What does x stand for? It stands for all the numbers that would make the inequality true. Okay? So x, or my variable, always starts in the middle of my compound inequality. And then the symbols face x the way that our statement tells us. Okay? So it says a number x is what? Greater than -8. That means it must be open to the x compared to -8. That x is greater than -8. Now, I know in the past we've tried to reverse this and write the x first. We cannot do that with a compound. We must realize that this means x is greater because it's open towards the x. All right, the second part is a little easier. And less than or equal to, so what symbol needs to go underneath the less than symbol? The bar, right? Less than or equal to 4. Okay, so to write a compound inequality, okay, this is an and statement where my solutions are connected together. This is an and statement, okay, meaning that in order to be a solution to this inequality, x must be greater than -8, but it must also be less than or equal to 4. And I'm going to show that on a number line. The way I graph compound inequalities is a little different. I'm going to graph what's called boundary values, because with a compound inequality, my answers don't necessarily go to infinity. There are boundaries for my solution. All right, which one is the lesser of the two values? Which one? Which one's lesser? Okay, -8. Okay, so -8 would go down here towards the left because it's the lesser of the two boundary values. And 4 would go up here towards the top. Okay, 4 goes towards the top. All right, so now would it be, according to my symbol, would it be an open dot or a closed dot on -8? Open. It would be open. And would it be open or closed on 4? It would be closed. Okay, and if x must be greater, that means that my values are going to trend to the right, but it also must be less than 4, which means between the 4 and the -8, the values will go to the left. So guess what? They connect. And you see how I'm making this line much more bold? Okay? You need to do that to really emphasize that your solutions are in between. And notice there are no arrows. That's on purpose, because no longer do my answers go off into infinity. They are confined to these boundaries. Okay? Here's what I'm saying. All right, give me one number, and I do want this, okay? I need one number in between. Give me one number in between -8 and 4. Give me any number. 3, 2, -7, okay? 0. It doesn't matter. You can put any number. Say, well, 0 is closer to +4. I don't care about which one it's closer to. Just give me a number in between. Here's what I'm saying, okay? That all the numbers in between these two values will make the compound inequality true. So let's take 0 for example. If I were to plug in 0 for x, is 0 greater than -8?
Yes. Yeah.
Is it less than or equal to 4?
Yes.
Yes. If I take any number outside of these boundaries, it's not true for both. Like let's say I took a 6. Okay, the 6 is way over here. Is it true that 6 is greater than -8?
Yes.
Yes. But is it less than 4? No. Okay, so you see what we're doing here with a compound inequality. With the and statement, it has to be true for both sides. Now, let's look at the next one. A number y is at most 0 or at least 2. So now, again, I'm looking for a key word here. A number y is at most 0 or at least 2. This word or here, this is not a part of saying greater than or equal to. Do you see that? Or less than or equal to. This is an or. This is an option. This could be either. So an or statement could be one or the other. It does not have to be both. So here's how I write an or statement. Y is at most 0. How would I compare y to 0 if it was at most? What inequality symbol would be facing the y? Colin? No. Less than or equal to. Less than or equal to. Okay? Or, here's another option. So for the and, they're connected. For the or, it's one or the other. Same thing, y, and I would highly suggest that you write your variable first, is at least 2. So what symbol would I use to compare y to 2 if it was at least? Samuel?
Greater than or equal to?
Very good. Greater than or equal to. So for an or statement, I'm still saying, here are my boundary values. So when I put it on a graph, I still want my values. Kind of inch them in a little bit on the number line. You'll see why in a minute. Okay? Which one is the lesser of the two values? 0 or 2?
0.
0. It's very important, guys. Listen to this, because this will actually come here in just a minute. No matter what the order is that you write it, that you put the lesser of the two values to the left. Okay? Put it in the correct order on the number line. 0 and 2. Would it be, according to my statement, would it be a closed dot or an open dot?
Closed dot.
Closed dot. Okay. And again, going back to my statement, if it's less than or equal to 0, which way does my arrow go? If it's less, to the left. It goes to the left. So I want you to shade in that line, make it nice and bold, okay, and do your arrow. Arrow going left. Okay, now open dot or closed dot on 2. Closed. And which way does my arrow go? To the right. So what we see happening on an or statement is we see a split. We see a gap. Give me a value in between 0 and 2. I still want this number on your number line. Give me a value. What's the obvious one? 1. Okay? Now, these values in between are the ones that are not solutions. Notice nothing is bold lines. There's nothing in between, because look what happens if I try to plug in one of these numbers. Is 1 less than or equal to 0 if I plug in 1? Is it less than 0? No. Is 1 greater than 2? No. So what I'm showing in an or statement, okay, is that my answers are actually going in opposite directions, and I kind of like to call this space in between, it's kind of like no man's land, okay? None of these answers in between the values are solutions. But literally any other value, give me a number greater than 2. 3. As long as, look here, as long as it makes one of them true, it's a solution. Is 3 greater than 2?
Yes.
Yep. Give me a number less than 0.
Negative 1.
-1 is -1 less than 0?
Yes.
So then it makes it true. As long as the solution makes one of them true. Are you guys following along? Y'all seem a little restless. Okay? All right. So example 2. Example 2. Sorry, yeah, I know. I was about to move on to example 2, but I forgot we're doing a classwork problem. Okay, so you need to decide on this classwork problem, is this an and statement or an or statement? And then you're going to write it. Remember, we just did 2, okay? So you're going to write the statement and graph the solution. Write the statement and graph the solution. I'm just going to walk around and check on you guys. So number D is more than 0 and less than 10. Remember, D goes on the inside, it goes in the middle, and it's more than 0, so it's opened up. This is saying that my values must be more than 0. Okay, you guys did really well with that. And then it must also be less than 10. So my boundary values are graphed on the number line. I have 0 and 10. And remember, you just need one random number in between. So what number did you pick? 5. I like 5 too because it's halfway. Okay, any other symmetrical people out there? Okay, all right. I like things to have some kind of a pattern. Okay, now open dots. Did y'all do open dots?
Yes.
Okay, and my line is connecting them. This was an and statement. All right, and I think pretty much everybody caught that there was an and here, which meant that my values must be combined into an and statement. All right, very good. Now, in examples 2 and 3, we're going to solve these inequalities. All right, in example 2, I'm solving and statements. And that's what I see here, that my solution, okay, my x is connected to both sides of this compound inequality. So what do I mean by solving? I mean that there now is going to be an operation connected to x. And I'm going to solve this the same way that I've solved my other inequalities. How can I get x by itself in the middle? How can I get -2 to cancel out?
Add 2.
I need to add 2. And whatever I do to the middle, I must do to each side of my compound inequality. Okay? And now my 2 in the middle cancels. What's -4 plus 2?
Negative 2.
-2 is less than x, which is less than, what's 3 plus 2? 5. I want you to go ahead and graph your solution now on your number line. Go ahead and graph your boundaries and your solution on your number line. So did you get your boundary values on there? -2 and 5. Are they open or closed dots? Open. And then just get a value in between. It doesn't matter, just any value. And I just kind of color in my line in between, showing that my solutions connect. So tell me this. Tell me, what am I showing about the solutions to this inequality? What am I showing here by how I graphed it? Hadley? Okay, they're connected. Give me any value, doesn't have to be 0, that's greater than -2 or less than 5. 3. Okay, so let's go with 3. Plug in 3 up here. What's 3 minus 2? What's 3 minus 2? 1. Is it true that 1 is greater than -4 and less than 3? Both. Yes, it fits into that range. So what we're showing on our graph is these are the values that I could plug in for x and it would make it true. It would fit. Okay? All right, so now let's look at the second one. Let's see. Hope. what do you think you would do first on this second one? I've got this negative 2x plus 1 in the middle, and I need to get x by itself. What do you think my first step would be? Very good, to minus 1. So when I minus 1, I minus 1 from each side, minus 1 from each side, and then I'm going to rewrite my inequality. 2 is less than negative 2x, which is less than or equal to 8. All right? Colin, what would I do now to get x by itself?
Since it's multiplication, you would divide it by 2?
2 or negative 2. If that's a negative, I got to divide by a negative. Negative 2. Oh, wait. Does anybody remember what happens if a negative is connected to my variable? Oh, my goodness. What is going on? So what's 2 divided by negative 2? Negative 1. But now instead of it being a less than symbol there, I need to reverse it. I do. And so now x is greater than or equal to, what's 8 divided by negative 2? Negative 4. So now I have something that's honestly kind of written a little backwards, okay? But remember how it reads compared to x. I'm saying that x is what compared to negative 4? Greater than or equal to. Do you see how it's open? And then x is what compared to negative 1? Less than negative 1. So on my number line, I still must, to the left, put the lesser of two values. Which one is lesser, negative 1 or negative 4? Negative 4. So even though that one came second, I still must graph it in the correct order on my number line. Okay? And a negative 1. Okay? So now, again, how it reads is x is greater than negative 4. So my values start trending to the right, but it's also less than negative 1, which means those values would trend to the left, and they would still connect. All right? And then I just have my open dot on negative 1 and my closed dot on negative 4. All right? And my graph still works, even though I had to reverse my inequalities. Okay, so look here, guys. Watch this. All right, give me a value in between negative 1 and negative 4. Give me a value. Any value. Negative 2, okay? All right, so put that number in here. Now watch what happens when I come back in and plug in negative 2 here. What's negative 2 times negative 2?
4.
Positive 4. What's 4 plus 1?
5.
Is 5 greater than 3?
Yes.
Is 5 less than 9?
Yes.
And had I not reversed my signs, I would not have gotten that correct. And the reason why is because there's a negative connected to x, so then I'm multiplying by a negative. All right, so I just wanted to show you how it really does work out. Okay, that those values in between the values, those are the only solutions. Okay, the only solutions. All right, let's do or. These are the last two, okay? Just two more. So these or statements, remember what we said about or. It can be one or the other, but it doesn't have to be both, okay? So now I have one to solve, and I have another one to solve. We're going to solve them separately, okay? So go ahead and start solving this first one. Go ahead and start solving the first one. Okay, so what you do now, guys, look up here. Add 5 to both sides. Add 5 to both sides. 3y is less than negative 3. Does this require me to flip my inequality? Nope. No, thankfully. Y is less than negative 1. This is only part of my answer. Don't box it in. Now, solve the other one. Now, solve the other one. Go ahead and solve the other one. So, what do I do first? Guys, stay with me. What do I do first? Add 1 to both sides. 2y is greater than 6. Divide both sides by 2. And y is greater than 3. Now your or goes in between them. So what it's saying is that your solution can be less than -1, or it can be greater than 3. And you will show that on the same number line. Plot your boundary values. Which one is lesser, -1 or 3?
-1.
-1 and 3. What's a number in between? 0, 1, 2. Okay, well, we're going to come back to that number in the middle. Now, is it an open dot or a closed dot at -1?
Open.
What about 3?
Open.
Okay, now read it, guys. Y is less than. Less than. Less than goes left. Y is less than -1. Okay, hold on. And greater, hold on, greater than 3. So with or statements, what I'm saying is the values in between here are not going to be solutions. Okay? Take 0, for example. If I were to plug back in 0, 3 times 0 is 0. Okay? -5 is not less than -8. And if I were to plug in 0 over here, -1 is not greater than 5. Basically, what I'm saying is, guys, is now all the numbers in between here, these are the only numbers that would not be a solution. Because if I pick any number greater than 3, it's going to make the one on the right true. If I pick any number less than -1, it'll make the one on the left true. It could be either one. All right, so now we're going to do this last one. I want you to do this one on your own. Solve both sides and graph your solution. I'm going to walk around and check on you guys. Okay, add 3. No, subtract 3. Subtract 3 from both sides. 4c is less than or equal to -8. Divide both sides by 4. Do I need to reverse my inequality?
No.
-2. But I'm not done. That's only half of it. So now I need to come over here and add 8. And now c could also be greater than 9. This is my or statement. Okay, this is my or, so it can be both. So now I need to come down here to my number line. Which one is smaller, -2 or 9? Okay, -2. Open or closed dot? Closed. And since it's less than -2, which way does my arrow go? To the left. Okay. All right, let's come over here to 9. Open or closed dot? Open. Arrow going to the right. It's greater than. All right, give me a value in between these two values. 5, 3, 0, any number. What do we know about this number?
It's not valid.
It's not valid. It's not a solution. If I were to plug in any number in between these, remember my arrows are going out, showing me where my solutions are. If I plug in a number in between, let's say 5. What's 4 times 5?
20.
What's 20 plus 3?
23.
Is that true? Is 23 less than -5? No. So take 5 up here. What's 5 minus 8?
5 minus 8 is 3.
-3? Okay. Is -3 greater than 1?
No.
No. -3 is not greater than 1. So what we're saying is all these numbers in between would not be solutions because it doesn't make either one true. All right. Now, if you take all these numbers, that makes this one true. If you take all these numbers, that makes this one true. And one or the other would be fine. So this is how I graph it. Okay, this is how I graph it. All right, that's it for compound inequalities.